All right, hey guys, I wanted to do another example with you today, just on normal distributions and percentiles. And so, first question here, we've got some data that's normally distributed. What scores lie at the 75th percentile? And so the point of these problems is that when I'm giving you the percentile, I'm actually giving you an area. I'm saying, what score has area 0.75% to the left of it? Let's actually write that down. So we want area equals 0.75 to the left of your score. And the idea is that right to the left means that 75% of the area lies below you. So that's good news for us off our chart because we can pull area to the left when the z-score is positive off the chart. So let's hop over to our table. And I'm just looking on the table, and I want the area to be as close to 75 as I can get it, 0.75 as I can get it. So looking at the chart, I'm going to have to do some estimating because things aren't exact. You can see one option here is 0.748 and then 0.7517. So I need to average these two values. And so if it's easier for you, write down the actual z-score for this value. So that's what, 0.67. So 0.67 is 1, and then the other one is what? Where were we? Right here. I get 0.68. So I want to take the average of those guys. And when I do, I'm going to get 0.675. That's just sort of the midpoint between them. So that's the z-score. 0.675 is the z-score. You can look on the table, right? 0.67. And you're going to get roughly 0.75. That's all I'm doing. And I'm going to erase that off of here. So 0.675, we'll go back now to our problem. And so we know that the z-score is 0.675. And now the question is, what score, what actual data lies at this percentile? So you say, well, x is the mean. Let's remind ourselves the formula. X is mu plus z times sigma. So I get x is what? 64 plus 0.675 times 5. I'll have to use a calculator real quick to do that with you. And I get what? 0.675 times 5 is 3.375 plus 64. And the point is you get a 67.37. So this score is at the 75th percentile. So I would encourage you to pause the video and try your hand at the 90th percentile. This works best if you'll try it and not just watch yourself. So pause it. All right, welcome back. Hopefully you were able to work it out. Let's do it together. So what score lies at the 90th percentile? I'm looking for the z-score that gives me area 0.9 to the left, where it's 90th percentile means 90% are below me. That's to the left. So I go over to my table. I'm looking for as close to 0.9 as I can get, so somewhere, they keep going, somewhere right here. I'm going to take the average of those two, and I get what, 1.28 and then 1.29 are my two scores, so we'll use 1.285. And so I get z equals 1.285. I want to double check that actually. I don't want to mess this up. Let's just make sure that was right. 1.2 and then 8 puts me right below 0.9. Yeah, that's it, 1.285. Okay. So that's my z-score. So then my exam score is just 64 plus 1.285 times 5. And let's run the numbers. 1.285 times 5 plus 64. And I get a 70.425. And we'll keep that as our score. So that's the score that lies roughly at the 90th percentile. We can only get so exact using a table. Okay, and then it says at what percentile is a score of 64? I put this on here as kind of a trick question. So why don't you pause the video and think about it for just a moment. At what percentile is a score of 64? Well, 64 is the mean. Okay, and if you understand what's happening, the area is split at the mean, so 50% of the area lies above and 50% lies below. It doesn't matter whether or not we include 64. The point is 64 lies at the 50th percentile. And that's, I don't have to work to get that. I just know it's the mean. So I did want to do one where we actually have to work. So for this one, why don't we pause the video and see if you can work this one out. Okay, so percentile, how much of the data is below a 52? I want to go ahead and get the z-score. And so I'm going to get, well, 52. Let's actually, write down the formula for z. So z equals the data 52, subtract the mean 64, divide by the standard deviation, which was, I believe, 5. Yeah. And so what do we get here? We get minus 12 over 5. And let's actually switch that to a decimal. And I'm going to get 2.4. So minus 2.4. So that's the z-score. Okay, so I want the area to the left of negative 2.4. And we know that by symmetry, that's the same thing as the area to the right of positive 2.4. And we know that's 1 minus the area to the left of 2.4. I'm sketching the picture so you can see it. So this is going to be 1 minus, and then the z-score for 2.4. So I'm going to go over to my table, and I can find 2.40. 0 is the first column, so 2.4 is just 0.9918. So 0.9918, 1 minus 0.9918, and I get 1 minus 0.9918. I get 0.0082. So we're going to round that to 0.01. And so we would say, so 52 lies at the, we're just going to say first percentile. Not even quite 1% of the data is actually below. Okay, so that's it. I hope this is helpful. I'll post these notes under Teams. Why don't we look under video notes? I'll make a folder called video notes. All right, ciao.